So space is the implied sending item. So space is the implied sending item for receiving items of category alphanumeric edited, DBCS, national, or national edited. So just like here, spaces, it is the implied since we're receiving an alphanumeric or alphabet from this one, from A. But if it is numeric or numeric edited, so 0 is the implied sending for receiving items of category numeric or numeric edited. So our example, so here we have the value of x 1, 2, 3, 4, 5. So y, we have a value of 0, a, value of a, b, c, d, e, and b, the spaces. So what happened here when we display x? So it display the full value of it since it has the same size to the declared variable. So in y, you may notice why it is plus 345 when it has a 0 value. So it means that we move x to y. So when we display a, we display the full value of a, which is a, b, c, d, e. But when we display the value of b, as you may notice, when we move the value of a to b, which is to copy a from b, the size of b has lesser than the value of a. So we need to remove the last two digit at the last two alphabet of the value a, which means abc would be displayed to value b. So as you can see, when we display a field, we are copying abc to a field, which means that the value of a field will become abc. So b field, when we display b field, we copy 123.45. Actually, when I this one, when I run this one in the compiler, this was the result. But to be honest, the actual result for that b field would become 123.45 plus the sign of it. In the IDE, this is just the result. But when I review it today, I realized that it was my mistake not reviewing it again. So the value of work is low value, which is, this one is correct. Actually, this one is correct. Since low value is a constant that is equals to 0, just like the spaces. So when we initialize work, it becomes 0, 0, 0, 0, 0, 0. So when we print again the a field, it should return a space. For this one, since I already have 123.45, it returned to 0. So when we initialize work, the alphanumeric would become a blank space. the numeric would become 0. Then, for work, it becomes 0. So all our identifiers or literals that precede the keyword to are added together, and this sum is added to the and stored in identifier 2. This process is repeated for each successive occurrence of identifier 2 in the left to right order in which identifier 2 is specified. So we add x, y, z to p and q. So meaning x, y, and z is equals to p. X, y, z is equals to q. So we have a value of p of 2.1 and q which has a value of 6. So what it does, if we add p to q, it would return 8. 8 since q is doesn't have a decimal value. But if it has a decimal value, it would return 8.1. So that's the explanation of here, 8. So if we add 1 to z, which has a value of 4, it would return 5. If we add p to q and it is rounded, it would return 8. But if q to p, we add q to p, meaning our value would become 8.1. But if it is rounded, it would return 8. So add x to y. When we check here, it says add error. It is printed first because as you can see, it is an object it is a procedural programming. So this is displayed first before it is displayed. So when we add x to y, so 81 plus 80, that would be 161. But if we store it to y, the value of it is already exceeded since the size of y is 2. So meaning, just like throwing an error, on size error, then we display the add error. Since we cannot store it to the variable y. But if it is 9 parenthesis 3 or the size of 3, then it would not throw an error. So all identifiers or literals that precede the keyword to are added together, and sum is added to identifier 2 to obtain a temporary sum. But if we are going to store it, so meaning it is just a temporary sum. So by adding giving to p, meaning to a new variable, so if we add x, y, z to v, so and give it to is just like equals p, so this value would have p would have the sum of these uh, variables. Example, 1, 2, 3 plus 4, it would return 10. So if we are not using giving, it would be stored to v. But since we are using giving, so basically the value would be stored, the value 10 would be stored to p and not to v. So v would remain its value after adding it. So subtract all identifiers or literals preceding the keyword from are added together. Their sum is subtracted from and stored immediately in identifier 2. this process is repeated for each successive occurrence of identifier 2 in the left to right order in which identifier 2 is specified. So when we subtract x, y from p, q, uh, meaning that if we add this one and then subtract it to p, like 1 plus 2 is 3 minus 3 would have a result of 0. 1 plus 2 minus 4 would have a result of 1, a new variable which is 0 and 1. Then, so just like addition add semantics, uh, we can store it by to a new variable by using giving. So meaning x plus y minus p is equals to q. So 1 plus 2 minus 5, so minus 5 is equals to 2. So meaning even if we have a value of q, we we override it with the value from the subtract uh, method or verb. In format 1, the value of identifier 1 or literal 1 is multiplied by the value of identifier 2. The product is placed in identifier 2. For each successive occurrence of identifier 2, the multiplication takes place in the left to right order, in which identifier 2 is specified. So x by p and q, meaning that x times p would give us like 2 times 4 is equals to 8. 2 times 5 is equals to 10. But if we have the 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 usage of the giving, storing it a new variable, so 2 times 3 would give us 6 and override the value of z, which is equals to 4. Just like divide, so y divided by x and z divided by y, ix. So meaning 7 divided by 3 would give us 2 and 12 divided by 3 would give us 4. So if we want to store it a new variable, the same uh, uh, steps, so 13 divided by 2 would give us 6. So in this format, we can also store the remainder to another variable. So just like the steps before, the only we can copy the steps we used a while ago, and the remainder we can use the remainder keyword to determine what is the remainder between x into y, or y divided by x. So when we divide 9 divided by 2, which it is equals to 4 and has a remainder of 1, it is stored, the r here is being stored, has a value of 1 after dividing y into x. So compute can be used to initialize a numeric field, usually reserved for non-trivial computations. For simple computations, choose add, subtract, multiply, or divide. So if if your calculation is just an add or a subtraction only, then don't use compute. But if it is complicated one, a longer a combination of add or maybe subtract, you can use the compute. So here the value of x, which has a value of positive 4 digits, uh, and decimal 0. So a plus b divided by 2.3. So if it would uh, exceed the size of 4, or maybe the or the decimal value or size, then it would display x was truncated. So the arithmetic operators are used are addition, subtraction, minus, times multiplication, slash division, double, asterisk, exponentiation. So parentheses provide precedence. Always parenthesize. So here, so x plus y. So it would add the x plus y first. Here, z, exponentiation of 3. So z raised to the power of 3. Then after having that result, it would multiply the result of x plus y and the z raised to the power of 3. So the flow of control. There is theoretical result in computer science by two Italian mathematicians, Born and Jacopini, that states that only three control structures are required to write any program. That is sequence, do this, now do this, now do this. Selection, if something is true, do this, else do that. Repetition, while something is true, do this. Practice has shown that being able to create procedures is helpful in overcoming complexity, but they aren't strictly necessary. One implication of this result is that go-to statements aren't needed. So, the example, this is the example of flow control, or an if the loop, uh, for instance, that if it is true, it would give this value. If false, it gives this value, or maybe it would exit the loop. That while it is true, it would continue looping, while false, it would exit the loop. If the condition is tested, and if the condition is tested and either the true or false blocks are selected for execution, don't use next sentence if you are using and if as the delimiter, and you should. Use of next sentence causes execution to continue with the next closest period, which is probably the end of the paragraph. So example, if x is lesser than y, add 1 to x and display triple A. Else display triple B. And if x is greater than y, display x was bigger than end if. Always use end if to end the if else statement. The nested ifs, each else is matched with the nearest preceding if. Example, if x is lesser than y, display triple x. If x is lesser than z, display z. Else, display triple A. Then and if. So moral lesson of this topic: indent properly and terminate all if statements with and if. So indent properly, so it would become a readable code. So you won't be confused of where uh, which else is connected to if statement. So it evaluate the identifier, literal, condition expression, arithmetic expression, true and false. Also, so meaning when you evaluate, you can evaluate by one identifier, or using also you can evaluate one or more identifier or literal or condition expression, arithmetic expression, true or false. So then when you evaluate, you can use when, uh, also any condition that is true or false, or maybe not, identifier, literal, or arithmetic expression. True is to loop a certain range of identifier, a literal, or arithmetic expression. Then the state block. Then when other, so you have other when, so it is the repetition of this one. So when other, you, so go back to this one until you end evaluate. Our example here is evaluate planet number. So as you can see here, our planet number is set to 4. As you can see, we have already discussed the move, but we haven't discussed the set. The move here is only applicable to alphanumeric, but the set is only applicable to the number. So meaning when you set a number, so the variable name should be first, and the value should be uh, the last one. Unlike move, that the value would be first to be called, rather than the variable name. So when our planet number is 4, so it evaluate the planet number. So 4. So it check when 1, when 2 is evaluate is just like a switch statement. Like switch planet number case 1, case 2, case 3, and case 4, which is Mars. So we printed out the Mars. So when we evaluate the planet name, which is case example switch planet name, case Mercury, case Venus. So our planet number, so when we move Mercury to planet name, it check if this Mercury existed in this switch statement, or the evaluate statement. As you can see, it is a case sensitive.